Okay, let's dive in. You know how sometimes you read like one article, maybe some research, and it just clicks? Or maybe it makes you completely rethink something.
Mm-hmm.
Well, that's really what we try to do in these deep dives. We take the source material people send us, cut through the noise, and get right to those key insights, those moments that make you go, aha.
Exactly. It's about getting past all the clutter online and finding the really fascinating stuff at the core. We're sort of guides helping you understand what really matters in the material.
And today, wow, we are heading way out there, deep space. We're looking at a discovery that's genuinely, the baffling astronomers, making them question some basics.
Yeah, our main source for this is a recent piece from Live Science. It lays out the details of this really peculiar object. It's a great place to start to understand, not just what they found, but why it's so unexpected.
Great. So our mission today, unpack this source, figure out what this mystery object is, why its behavior is so weird, so unprecedented, and maybe, just maybe, what it means for like everything we thought we know about the universe.
Let's do it. So the object, it had one of those typical catalog names.
Yeah.
ASKAP J183209-01.
ASKAP J183209-01.
ASKAP J183209-01 rolls right off the tongue. But its behavior is anything but typical, right? The article says it's flashing strange signals from deep space. But flashes, that doesn't quite cover it, does it?
No, not really, because these aren't just random blips. It spits out pulses of radio waves and X-rays. Now, seeing radio waves, common. X-rays, also common.
Okay.
But seeing both, and with this specific timing, well, that's the kicker.
Ah, the timing. This is where it gets really wild, isn't it?
Uh-huh.
These pulses aren't quick little flickers. They last for, what was it, 2 full minutes?
2 minutes straight. Yeah, just imagine that signal from deep space just switched on for 120 seconds.
That's not long, and then it repeats.
And then it repeats, but not randomly, with this like almost unnerving precision once every 44 minutes.
44 minutes, that kind of long, regular interval. Astronomers didn't really have a box to put that in, did they?
Not really, no. It was definitely outside the known categories. So how did they even find this thing, this cosmic metronome doing its 2-minute on, 42-minute off routine?
Well, the first detection, that came from the Australian Square Kilometre Array Pathfinder, ASKAP. That's where the name comes from.
Got it, ASKAP.
And crucially, it wasn't just a maybe or a one-off glitch. Its existence, its weird behavior, it was confirmed by NASA's Chandra X-ray Observatory.
Chandra. Okay, so the big guns confirmed it. And you mentioned that dual detection radio and X-rays is important.
Hugely important. We'll definitely circle back to why that adds such a critical piece to the puzzle.
Okay, but before we get to the X-rays, let's just really understand why this 44-minute pulse is so weird. The article calls it an LPT, right? A long period transient.
That's right, LPT. And we knew about things that pulse, of course. Like pulsars?
Yeah, pulsars. Those are neutron stars spinning incredibly fast, beaming out radio waves like cosmic lighthouses.
Exactly. And they pulse, multiple times a second, sometimes thousands of times a second, millisecond.
Blink and you miss thousands of pulses.
Pretty much. So LPTs, the long period ones, they were already kind of mysterious because they pulsed much slower, like minutes or hours apart. They hinted something else was going on.
Okay, so LPTs were already the slowpokes, the weird ones. But this object, it's not just the long period, it's the regularity at 44 minutes. That combination was the real shock.
Spot on. That precise long period pulsing, it didn't fit neatly. Not with pulsars, not even with a few other LPTs we'd seen. This specific clockwork behavior is what's really forcing astronomers to, rethink things.
Okay, so when scientists find something this alien, basically, what do they start thinking? What are the usual suspects? Their article mentioned a couple of theories.
Yeah, the main contenders they're looking at.
Yeah.
One is a magnetar.
Magnetar. That's the super dense core of a dead star, right? With insane magnetic fields.
Insane is the word. Like unimaginably powerful magnetic fields. The physics gets pretty wild there, so maybe that could explain it.
What else?
The other idea involves a binary system. So 2 stars orbiting each other. And in this scenario, one of the stars would be a white dwarf. That's the end state for smaller stars like our sun, but a highly magnetized one.
A magnetized white dwarf and a pair. Okay, so those are the leading ideas based on what we kind of know.
Those are the prime suspects, yeah, based on objects we know can produce pulses.
But then comes the really interesting part. The researchers, quoted right there in the article, they basically say, even these best guesses, they don't fully work. They do not fully explain what we are observing.
And that's where it gets exciting, isn't it?
Yeah.
It means this isn't just slotting into an existing category. It's potentially breaking the mold. The lead author says it flat out. It's unlike anything we have seen before.
Unlike anything we have seen before. That's strong. And the implication they draw from that is huge. They suggest this could point to, what? New physics, new models of stellar evolution.
Exactly. Think about that. Finding this one object, this one weirdo out in the cosmos, might mean we need to actually rewrite parts of our physics books.
Right.
Or fundamentally change how we understand stars living and dying. That's massive.
Wow. Okay. And this is where that Chandra X-ray detection comes back in. You said it was a game changer.
Absolutely essential. It wasn't just, yep, it's there. It was apparently kind of a lucky break. Chandra just happened to be looking in the right spot.
Huh. Cosmic luck.
Right. But that luck gave us the first ever detection of one of these LPTs and X-rays at the same time as the radio waves.
The first ever simultaneous detection. That is a big deal. So what does seeing both tell them? What's the extra clue?
It adds a really tough constraint. Any theory you come up with, now magnetar, binary white dwarf, something totally new, it has to explain both. Why is it pumping out radio waves and X-rays together on that exact 2-minute pulse, 44-minute cycle?
Ah, I see. It's like before you only had to explain the radio signal, but now your theory has to account for both outputs at the same time. Makes it harder for the old ideas.
Much harder. But it also gives us a much clearer target for any new ideas. You know what features your explanation needs to have.
So, okay, if the current theories are, let's say, struggling, and this thing might be hinting at new physics, what's next? How do they figure this out?
Well, the researcher's suggestion, mentioned in the article, it's straightforward conceptually. They need more examples.
Find more of these weirdos.
Exactly. Find more. And crucially, observe them simultaneously with both radio telescopes like ASKAP and X-ray telescopes like Chandra. Get more of that dual emission data. Build up the picture piece by piece.
Makes sense. Seeing just radio is one piece, seeing just X-ray is another, seeing them working together, that's the key.
And as the second author points out, just finding this one hints that there could be many more out there.
Right. It's probably not a complete one-off cosmic fluke.
Probably not. It suggests maybe there's a whole population of these things. We just, we didn't know how to look for them, our theories didn't predict them, so we missed them.
And that X-ray data is vital to understanding them, right? The quote goes on, "The discovery of its transient X-ray emission opens fresh insights into their mysterious nature."
Yeah, it's like suddenly getting a peek under the hood. Think a bit more of what makes this strange engine tick.
So for you listening, thinking about this puts you right there, right at the edge of cosmic knowledge. This isn't some dusty old finding. It's the universe actively challenging our ideas right now. About physics, about stars.
These are the kinds of discoveries that could potentially lead to those huge paradigm shifts, those moments where our whole understanding gets reshaped. It really reminds you how much we still don't know, how much fundamental stuff is still out there waiting.
Okay, so let's just quickly wrap up this deep dive. We've looked at ASKAP J183209-01.
This mysterious object pulsing both radio waves and X-rays.
For 2 minutes straight.
And then repeating precisely every 44 minutes.
And that precise long period beat. It just doesn't fit our current best explanations. Not magnetars, not binary white dwarfs, not really.
Right. It defies them. Which points towards something potentially brand new, maybe, like the researchers suggest, a new type of physics or new models of stellar evolution.
And detecting both the X-rays and the radio waves together, that was huge, a vital clue.
Yeah, a critical piece of the puzzle. Any explanation has to account for both signals happening together like that.
So the plan now is to find more of these objects, watch them closely with different kinds of telescopes at the same time, and hopefully start to crack this cosmic code.
Which kind of leaves us with this final thought to mull over. This one object, ASKAP J183209-01, doing something we thought was impossible, or at least highly unlikely.
Right.
It's actively pushing the limits of what we know.
Right.
So it really makes you wonder, if in just one little patch of sky, we could find something so unexpected, so fundamentally weird, what else is out there? What other surprises are waiting in the universe that are completely outside anything we've even imagined yet?